The title of Chapter 8 should really only be air masses. Air masses because everything in that chapter relates to either their formation, identifying them, or moving them and creating weather. So in a nutshell, air masses is what Chapter 8 is only about. So let's talk in length about air masses. It can be, I've learned from students that this can be a little tricky subject to understand. So let's delve into this just a little bit. Air masses are simply a common air with common features. So when we say features, we're normally just talking about temperature and humidity. So over a wide area, and it's not very precise lines. We're talking about just a very large area, say, the size of the entire Midwest, or the size of Texas to South Dakota. A very big area. That whole area is warm and moist, or cold and dry. And we're talking about very general terms here. The temperatures are all in the 50s and the dew points are all in the 20s. That is an air mass. Similar characteristics over a very wide area. Where do they form? Well, if the air has similar temperature and moisture over a very big area, you need a big area for it to form in. And then you need similar characteristics over that entire area. Easiest example would be the Gulf of Mexico. The Gulf of Mexico is both warm and moist. It's nothing but water, right? And it's very warm water. So the air over the Gulf of Mexico becomes warm, and it picks up a lot of moisture. So in that case, that blob of air that's over the Gulf of Mexico starts to move, and as that whole blob of air starts to move, that's an air mass that is warm and moist. And on the flip side, think of an ocean of land. An ocean of land, say in the middle of Canada, would be very cold, especially in the winter. It would be very cold, and there's no water resources, at least not in comparison to an ocean. So it is cold and dry. So those, we're talking about general terms in air masses. So we can't just say, we normally don't just say this is a warm and dry air mass. We actually give it a technical name. We give it either maritime for water-based, or continental for land-based. Maritime means it's moist. Continental means it's dry. Then we give it a name in terms of temperature. So tropical means it's warm. Tropics, right? Makes sense. And polar means it's cold. Just think North Pole. Cold. Okay? Those are the names. Now, characteristics of each. Let me get into those. There's really only 4 basic air mass types that you'll need to know in general. There's another one. You can distinguish polar and Arctic, but really, for this discussion, I'm only going to worry about 4. They are maritime tropical, continental tropical, maritime polar, and continental polar. What I said before, maritime or continental, talks about their moisture. Maritime, ocean, water, think moist. Continental, land, dry. Okay. Tropical means warm. Polar means cold. So, maritime tropical means it's moist and warm. This would come from someplace like the Gulf of Mexico. It's very important in terms of weather. Maritime tropical, those air masses are almost solely responsible for the very severe thunderstorms that we get in the springtime in the Great Plains of the United States. Then continental tropical is a warm and dry air mass. Those warm and dry air masses typically come from the southwestern portion of the United States. The boundary between the maritime tropical air mass, where it's really warm and moist, versus where it's really warm and dry, that's called a dry line. In the polar category, we've got maritime polar. Maritime polar are typically found and created over the oceans of the high latitudes. So, say the Arctic Ocean would have a maritime polar. It is cold and moist. Dew point can never exceed the temperature. So the dew point in the maritime polar air mass probably is not going to be greater than, ever greater than a maritime tropical, or even in some cases continental tropical. So there is a little trick there but just understand that typically the dew point is fairly close to the temperature in any kind of maritime air mass. The continental polar, the last one, is dry cold. The continental polar is almost entirely or exclusively responsible for the cold air outbreaks that the United States experiences, especially east of the Rockies. So when it gets really bitterly cold and it's windy from the northwest, that is a continental polar air mass rushing in, and that's why you experience a very cold and very dry air outside. Chapter 8 also talks about fronts, but fronts really go back to air masses. Fronts are nothing but the front edge of air masses. So when air masses start to move, that blob of air starts to move, that front edge of where the air mass starts is the front. So when a cold air mass is moving, the front edge of it is a cold front. When a warm air mass is moving, the front edge of it is a warm front. So when a cold front is approaching, it is either a maritime polar or a continental polar. Typically in the United States, certainly the central United States, you get mostly continental polar air masses moving in, and that's the cold front is always the same as long as it's a polar air mass. But behind those cold fronts is usually a continental polar. The maritime polar air masses moving in behind the cold fronts typically would happen on the Pacific Northwest and perhaps the far northeastern portions of the United States occasionally. Then in the cases where a warm front is moving in, the air mass is a tropical air mass because it's warm air moving in, and you typically see a maritime tropical air mass coming in from the south. Now, I should talk about that for a second. The cold front passing brings colder air in, so you would experience northerly winds because that's where the cold air is coming from. The cold air reservoir of the Earth is always in the North or South Pole. So over the United States, whenever you get a north wind, the temperature is typically going to fall. So behind a cold front, the air mass will have the same type of wind around the entire air mass. So you're going to have a northerly wind in a continental polar air mass. In a maritime tropical air mass, say coming from the Gulf of Mexico, you're going to have southerly winds coming on to Texas, Louisiana, Arkansas, into Missouri, Oklahoma. Because that warm, moist air is coming from the south, it needs to have southerly winds coming into it. So that blob of air has got the same temperature, humidity, and also the wind direction. Behind a dry line, which separates the maritime tropical and the continental tropical air masses, you have a wind switch from the south in the maritime to a southwest wind in the behind the dry line in the continental tropical area. Now that is because the continental tropical air typically comes from the southwestern portions of the United States. So we're talking about Arizona, maybe even into parts of Mexico. The reason it's dry and warm is it comes off the mountains, and so it subsides off the mountains. And if you remember back to those mountain problems, in the lee of the mountains, that subsidence warms the air and dries it out. That's why you typically get continental tropical air masses in places like West Texas and Colorado, and that's why the dry lines form out there, is because that continental tropical air comes from subsidence off the mountains. So fronts are the front edge of a moving air mass, but what causes an air mass to move in the first place? Well, like I said, they've all got southerly winds in a maritime tropical air mass, or they've all got northerly winds in the case of a continental polar air mass, so coming from the north or coming from the south, depending on the case. Why do the winds change? Well, the movers and the shakers, so to speak, of air masses are mid-latitude cyclones. Those big L's that are on TV when you're perhaps watching the weather. Usually the red L's that the weatherman is usually talking about, those low-pressure centers. Those are mid-latitude cyclones. And those mid-latitude cyclones stir up the atmosphere. They bring the air from the warmer areas and push them north, and they bring the cold areas from the north and push them south. And when those big blobs of air start moving, that's when you get those fronts. That's when you get weather to develop. So the big The big movers and the shakers, what causes the air masses to move are those mid-latitude cyclones. Now, I'm not going to talk too much more about that, but I do want you to pay attention in your reading to how waves in the atmosphere, those troughs and ridges, affect the formation and the formation location of those mid-latitude cyclones, and then also pay attention to how topography plays a very pivotal role in the mid-latitude cyclone formation as well. Specifically, in the lee of the Rocky Mountains, that is the main producer of cyclones in the United States.